So good morning everyone and welcome to this lecture. This is current electricity lecture number 6 and we are dealing with resistance and resistivity. In the previous class we had seen what did we do in the previous class? Anyone remembers? From the previous class what did we do? We were looking at finding out the resistance and we had seen that resistance depends on how we have connected
Yes, sir.
the body in different ways. If you connect them in different ways, we will have different resistance depending on what is the area and what is the length, and we started solving some questions based on it, where from resistance we had to find, from resistivity we had to find out resistance and so on. Do we remember this?
Yes, sir.
Okay, I think we have solved the question and we will be putting our efforts in solving question based on this, because this is the only part from where a question comes and which is different from what we have studied in capacitance. So on resistance and resistivity, we will solve a couple of problems and then we will see what happens if I stretch a wire, or those are the questions that come of stretching a wire. But before going on to stretching of the wire, yes, we will solve this question. This one based on the temperature. Remember, we had seen the formula of temperature. How does resistance vary with temperature? Do we remember that formula? Here is a question based on the same. The resistance of a wire at 20 degrees Celsius is 20 ohms and 500 degrees Celsius is 60 ohms. What is the temperature at 20? At what temperature will the resistance be 25? You have to tell me this one and I'll give you 2 minutes to solve this. Do you need a hint to solve this problem, or do you remember the formula? Do you need a hint? So the hint is on your screen now. Hint is on your screen now. This is the formula. From this formula, you can find out the value of alpha, and then you can use this formula. These are the two formulas that we had seen in blue box and yellow box. You have to use these two formulae. From the first formula, you can get the value of alpha, and then you can use the value of alpha in the second formula. You should get the value of t. That is, I think, what is asked here. They have given you at what temperature the resistance would be 60 degrees Celsius, 25 ohms. This is how you should do it. Let me do it for you, because this question may not come, because it requires a lot of calculations. So I'll solve it. I just wanted you to see what type of question will come in resistance, so I can use the formula. I had that formula, R1 by R2 is equal to 1 plus alpha into temperature T1 divided by 1 plus alpha into temperature T2. This R1 is 20 ohms and this T1 is 20 degrees Celsius. Do we understand this? This R2 is 60 ohms. T2 is 500 degrees Celsius. Do we understand this, everyone?
Yes, sir.
Solving this, you can get the value of alpha from this equation because alpha is the only unknown. Solving this, you will get the value of alpha as 1 by 220. Once you get the value of alpha, you can again apply this formula R1 by R2 is equal to 1 plus alpha into T1 upon 1 plus alpha into T2. Your R1 still remains this. Your T1 still remains this. The only thing is now your R2 will become 25. Are you getting my point?
Yes, sir.
You have already calculated the value of alpha. From there, you can get the value of T2 because alpha is already known. Do we understand this? So it will require some calculations. Those calculations may not come because they become too much. But you understand if any question comes, this is the way you are supposed to solve it. Do we understand this?
Yes, sir.
The value of temperature that I am getting, the answer that is given, not alpha. The value of temperature that is coming, T2, is coming as 80 degrees Celsius. So that is the answer for this one. I'll give you 1 minute to note it down. I hope everyone has understood this. Yes or no?
Yes, sir.
I'll give you 2 minutes to note it down. So we have done this question. Let us move on to the next one. And this is the next one. And these are the type of questions that you might get in your examination hall. So please do them carefully. This is the question. The specific resistance rho of manganese is 50 into 10 raised to the power minus 8 ohm meters. We will see the value of this, we will see the unit of specific resistance that is coming up, but just solve some questions, then we will go into it. The resistance of a manganese cube having length of 50 centimeters is how much? I'll give you 2 minutes to solve this. Cube is given, specific resistance is given. You have to find out the resistance of that cube between any two faces. 2 minutes you have. I have an answer here, and the answer is option C. That is absolutely wrong. How did you get option C? Again, mistake. Question number 2. So, how are you supposed to get the resistance of this? Resistance is rho into L by A.
Sir, option B, sir.
That is absolutely wrong as well. So how do you get the resistance? Resistivity is 50 into 10 raised to the power minus 8 ohm per meter multiplied by the, this is a cuboid. I mean, this is a cube. What is the distance between any two sides? That is the length of the edge. That is 50 centimeters, my dear friend. So 50 centimeters has to be multiplied by 10 raised to the power of minus 2 so that I convert it into meters divided by the area is 50 into 10 raised to the power minus 2 square, my dear friends. And when you are going to solve this, what are you going to get? This 50 square. So this 50, and this 50 will be cancelled. So 10 raised to the power minus 2 square, that is 10 raised to the power minus 4. What option are you going to get? 10 raised to the power minus 8 into 10 raised to the power minus 2 divided by 10 raised to the power of minus 4. And the answer that you are going to get is 10 raised to the power of minus 6. And that is the answer, my dear friends. Do we understand this? Anyone got this answer? Boys, girls, anyone got this answer? No one got this answer. I hope you have understood how I have done. Have you understood this, how this is done?
Yes, sir.
What mistake were you doing? What mistake were you doing?
So the length is in centimeter, but we didn't do it.
Okay, anyways, remember this.
So
This is
1 minute.
this is the next question coming up. A rod of certain metal, 1 meter long, zero point 0.6 centimeter in diameter. Resistance is given. A disc of the same metal, 1 thick, 2 centimeter in diameter. What is the resistance between the circular faces? Can you do this question now?
Yes, sir.
You have understood the second question. You just had to put the formula with the correct units. Yes or no?
Yes, sir.
You can do this question. I'll give you 2 minutes. Please do it. You just need to calculate and nothing else. So I hope you are. And remember the units, they are only going to do something with the unit. Sometimes they will give meter, sometimes they will give millimeter, sometimes they will give centimeters. So be careful about the units. Do we understand this?
Yes, sir.
2 minutes you have to do this question. Yes, bacha, anyone with any answer? How are we supposed to do this? This question. Hmm. Anyone? You just have to use the formula. Resistance is rho L by A. Now, for the rod, let me color it with blue. The rod is 1 meter long and zero point 0.6 in diameter. Zero point 0.6 in diameter. Let me call the resistance as R1. R1 will be equal to rho into L1 divided by A1 for the rod. So I can write it as rho is rho, length is 1 meter divided by diameter is zero point 0.6 centimeter. So radius becomes zero point 0.3 centimeters. So area becomes point into 0.3 centimeters. Remember the units. So 10 raised to the power minus 2 pi r square. You should not make any mistake with the area and the units. Do we understand this?
Yes, sir.
Okay, that is the value of R1. A disc of the same metal is 1 thick and 2 centimeter in diameter. Let me call that resistance as R2. That R2 will be rho into L2 by A2. Rho is rho. Length is 1 Remember, so 1 into 10 raised to the power minus 3 meters. Do we understand this?
Yes, sir.
Divided by pi into 2 centimeters. So 2 into 10 raised to the power minus 2 square. That is how you have to be careful. Now I can divide these two. I can divide these two and I will get R2 divided by R1 will be equal to Rho and rho will get cancelled, pi and pi will get cancelled. Yes or no? So what you will have? R2 divided by R1. You just have to be careful in this division. If you are careful in this division, you will find that this is 1 into 2 into 10 raised to the power of minus, oops, what I'm writing here. 10 raised to the power minus 2. Sorry, see, even I made a mistake. R2 divided by R1. So it is 0.3 into 10 raised to the power minus 2 square divided by 1 into 10 raised to the power minus 3. What I am writing here? I think I am writing reverse. See again. I always, in multiplication and division, I always make mistakes. Now this is how you must multiply and divide very correctly. From here, you will be able to get the ratio of R2 by R1, and R2 will become this thing multiplied by R1. A bit long calculation. You might not get calculation like this because this is more calculation based, and the answer that you are going to get is this one. But what I wanted you to understand from this question was this formula and how we use this formula to find out answers. Do we understand this?
Yes, sir.
The only thing is the calculation part. Such calculations may not come for you, but you must understand how to use the formula. Can you use the formula now? For one question.
Yes, sir.
Okay, this is the question. This question can definitely come in your exam. An aluminum rod of length 3.14 meter has a square cross section. What should be the radius of another rod of the same material which is 1 meter long to have equal resistance? So 3.14 meter rod has a resistance given to you, its area is given to you. We have to find out the radius. So now we have one rod which is square and one rod which is circular cross sectional area. So we have to find out this rod, the aluminum rod, is square in cross section. Do we understand this? Now I have one rod which is 1 meter long but circular in cross section, and I need both the areas, no, both the resistances should be same. Do we understand this question? Do we understand this question? Do we
Yes, sir.
understand this question? So I'll give you 1 minute to solve it better. Anyone got any answer for this? The formula for resistance is rho L by A. Now if I write the formula for this pink rod, the distance is R, that will be rho into L of this rod is 3.14 divided by the cross section area is 3.14 into 3.14. This is in meters and this is in millimeters square. So I just write the units so that I don't make the mistake. Then I move on to this blue rod. For this blue rod, the resistance has to be same. So I write the resistance as R, that will be equal to rho multiplied by the length of this rod is 1 meter. 1 meter divided by, I have to find out the radius of this rod. So this is equal to pi into R square, and the answer should come in millimeter because I'm not going to change the unit at all. Both the R's are same. So I should be able to equate both the things. 13.14, 13.14 can get cancelled. This pi and this pi will get cancelled. This meter and meter will get cancelled. So you will get your radius in mm, and you will get the answer as 1 mm. The radius of the wire has to be 1 mm. Do we understand this? Do we understand this? Girls, boys, I'm not getting your voice. Do we understand this, how this is done?
Yes, sir.
Why were you not able to do it? Can you tell me the reason? Why were you not able to do it? Can you tell me the reason? Okay, there are no reasons. That's good. Okay, we move ahead and we write the next heading that is known as resistivity, or sometimes we can also call it specific resistance. Everyone has noted down this question, yes or no?
Yes, sir.
Good. So we move on to the next thing, which is known as resistivity or specific resistance, rho. Now, we have already seen that the resistance of the wire is rho L by A. From here, you can find out the resistivity. Resistivity will be R into A by L. If you want, you can write it in this way. You can write it in this way. So now, if I put, I can write resistivity as R into A by L. If the length is 1 meter, area is 1 meter square, resistivity will be numerically equal to the resistance of the wire. Do we understand this?
Yes, sir.
Okay, from here you can find out the SI unit of resistivity. What will be the SI unit of resistivity? That will be equal to ohm meter. Ohm multiplied by meter, its dimension becomes ohm meter, its dimension becomes ml cube, t raised to the power of minus 3, a raised to the power of minus 2. Remember, resistivity, it is an intrinsic property of a body. It is an intrinsic property of the body, and it does not depend on the size or the shape. It depends on the material, which material or the nature of the material. It depends on the nature of the body. If it is made up of gold, the resistivity would be different. If it is made up of silver, resistivity would be different. So it depends on nature or material of the body. Do we understand this?
Yes, sir.
It depends on the nature or the material of the body. Last thing, it depends on the temperature. In fact, when temperature increases, resistivity increases. And if I tell you the formula of resistivity, resistivity at temperature T will be equal to R naught resistivity at 0 degrees Celsius into 1 plus alpha into T. So you can see this formula is exactly similar to the formula of resistance. In fact, you must understand that it is the formula of resistivity. From this formula of resistivity, we get the formula of resistance that we saw in the previous class. Do we understand what I am saying here?
Yes, sir.
What, sir? This formula that you see in blue dabba, in yellow dabba and blue dabba, this formula that you see in blue and yellow dabba is not actually the formula of resistance. It is the formula of resistivity from where this formula of resistance is derived. Do we understand this?
Yes, sir.
Everyone understands this. Now remember, this is the formula of resistivity for conductors or metals, but for semiconductors, you can see that resistance can decrease with temperature and therefore resistivity also decreases. So now, once you have written this, I will show you the graphs for metals, semiconductors, and superconductors. I'll give you 2 minutes to note this down. Please note it down fast. Since you have noted it down, let us now move ahead and see, as I told you, resistivity. Now, these graphs, as I tell you, these graphs can come as graph of resistivity versus temperature. These graph can also come as graph of resistance versus temperature. Do we understand this? So this is the first graph of resistivity with temperature. As you can see, it is almost same as a graph of resistance with temperature. Remember these graphs because I've seen questions where they have given you this graph and they have asked what they have asked. They have asked which graph refers to what, which type of body. So at that time, you must be good enough to remember these graphs. The second one is for semiconductors. Again, for semiconductor, resistivity decreases and therefore the resistance also decreases. And for superconductor, we have seen superconductor, they literally have uh, zero resistance, but when temperature increases, their resistivity increases and therefore their resistance also increases. I'll give you 2 minutes to note this down. Again, I will give you this uh, order of resistivity of different types of electrical material. Remember, resistivity of a insulator is very high, followed by the alloy, followed by semiconductor, followed by the resistivity of a conductor. Remember, resistivity of a conductor is very small. because they are conductors, therefore they are supposed to conduct, and therefore their resistivity is very small. I hope you understand this. Yes or no? No, yes.
Yes, sir.
Now, last thing that you can write is conductivity. Conductivity. We have seen resistivity. We can now understand conductivity written as sigma. What is conductivity? If you understand resistivity, you understand conductivity. Conductivity is the reciprocal of what?
Resistivity.
Yes, it is the reciprocal of resistivity rho, or I can say sigma is equal to 1 by rho, my dear friends. 1 by rho is sigma, 1 by rho, 1 by rho. So the SI unit becomes reverse of sigma. SI unit become ohm inverse, meter inverse. Ohm inverse can be written as mho. So you can write it as mho per meter. Do we understand this? Or this has gone above our head saying bye bye.
Yes, sir.
The dimension of this, the dimension of this becomes the reverse of the dimension of your resistivity. So it becomes m minus 1 L minus 3 T cube A square. Now I can also write the new formula of resistance. I can write it as L by sigma A. Do you understand how I got this formula, bacha? Instead of rho, I have written 1 by sigma, that is conductivity. Conductivity, my dear friends, conductivity. Do we understand this?
Yes, sir.
Everyone understands what we have done till now? We have come up till conductivity. We are almost to the end of this one. As soon as one more thing is left, stretching of a wire, and we will do that point in the next class. And so after that, we are done with this, and we will move ahead and see series parallel. Do you remember series parallel? Yes or no? Series parallel combination. Do you remember?
Yes, sir.
We'll again go to series parallel combination, this time for resistance, and do some questions there. I hope everyone has understood what we have done in today's class.
Yes, sir.
Okay, I'll meet you in tomorrow's class and we will carry on from there. Take care and God bless all of you. If you have any doubts, you can always ask me. Bye bye.
Bye, sir. Take care, sir.
Bye, beta.